So Gabby, thanks so much for coming on the Mr. Beacon podcast. I'm really excited about what your company FeelIt is doing. You're the CEO. And so in this conversation, what I wanted to do is just get an insight to this incredible technology you're developing. Can you describe what your company does?
Yes, so we developed nanotechnology-based sensors that basically can turn any objects into a kind of a self-aware object, being able to sense its structural deformation, structural movements, how it warps, how it, if there's a buildup in pressure inside. It's basically gives objects the ability to sense like we sense in our sense of touch. So, and it's very it has really cool properties because it's based on nanomaterials. So it's very, very sensitive, like the sensitivity of our fingertips. It's very it's low cost because it's printable, and it's low power consumption because its technology is based on it's kind of resistors that they sense when they're being deformed. So it's very, very low power consumption and very flexible. So it's kind of like artificial skin.
Incredible. So it's nanotechnology, and it is enabling objects to feel things, and that could be a kind of a stretching, a distortion on the object tension, or it could be like weight, I guess.
Yeah, it could be weight. It could be the way it bends. If you cover an object with it, so you'd be able to the object will be able to feel how it deforms. And of course, this is very interesting information and can give really knowledgeable insight on a lot of you think of products that can this technology can be implemented into the product, and by that give basically manufacturers of the product a way to stay linked to the object and to the product, and to understand how it is being used, how it moves, how it deforms. And there's like a vast amount of applications for this kind of concept. And yeah,
so it's a conductive material, isn't it?
Yeah, it's kind of a semiconductor material.
Okay.
So it has high resistance.
All right.
Therefore, low currents, low power consumption.
Okay.
Very low.
And so we're at the Wiliot offices in Israel, and it's kind of noisy around here, but it's also a real working office, and it's also beautiful, in my opinion. So we thought it would be a good backdrop, and I'm fascinated because of the applications combined with our product. But of course, your product could be integrated with all sorts of radios, not just ours. But tell me about some of the applications. Let's talk about the enterprise, but let's talk about the consumer applications first.
So basically, this can be applied because of its very low cost. It's printable sensors. Here is one of the examples of the sensor. You can feel it.
Okay. Oh man, this is absolutely tiny.
Tiny and very flexible.
Okay, I'm gonna just super flexible. So this you've printed this on a particular substrate, but this could be printed on a bottle, a bottle of scotch, exactly. Maybe on the bottom, and you could see the difference in the weight of the scotch as it gets drunk.
Yes.
And
so
potentially, if this is talking to a radio, then a Bluetooth beacon, for instance, then that could communicate with your phone, and essentially the scotch could reorder itself as you consume it.
That's one of the concepts that is basically possible, and we are now engaged in developing similar concept of different devices in the industrial production lines that can alert when something goes wrong with them, when something like if there's a leakage somewhere. So we apply these sensors on components inside industrial equipment. It's called predictive maintenance. It's to enable optimization of the maintenance of all the production line. This cuts down on material costs and energy costs and human resources. And now we're looking towards more large-scale applications, as you mentioned. This is why we're now working on large-scale printing of these sensors. Either directly on the product or on a sheet like that, which you can use as a sticker. So.
Right, so you could stick this on something, or it could actually be printed on the object. So what makes it printable, and what is the sensor made out of?
It's made out of nanomaterial that is basically semiconductive. That means if you put a potential difference on the material, current will flow, and it is very, very sensitive to deformation of this layer. It just basically changes distances between the nanomaterials, and it really changes the resistance of the sensor.
But I think you mentioned it's essentially ink and gold. Is that right? You have gold particles in there?
Yeah, this is, well, one of the materials that we use is gold. And
doesn't that make it super expensive?
Well, that's that's the initial thought about it, but no, we're printing really, really minute quantities of this special ink, and therefore, if your ring is made out of gold, so yeah,
how many stickers could you make out of this?
I guess millions of stickers.
All right.
Yeah, from one ring. So
then maybe it's not so expensive.
No.
So well, let's talk about price. How much does this cost at the moment, and where do you think it'll end up?
I believe that eventually we will be able to offer sensors and sensing technology to be applicable for commodity products. So yeah, we really want to try and use this technology to improve things in the world we're living in the sense of cutting down on energy consumption, material waste.
How could it be used to cut down on energy consumption?
In the example of the industrial application, industrial Internet of Things, to help do better maintenance of equipment. So there's huge amount of material and energy going down the drain because there are malfunctions that are either not detected, and then you realize at the end of the production line that something goes wrong because of the quality analysis of the product, and then you need to figure out what has gone wrong. And if you'd have some way of detecting a malfunction on the spot, or when it is about to occur, then you would really save a lot of energy and a lot of materials. And this is one example. Think of the savings you would have if, as you mentioned, a bottle would order itself. So that's a lot of effort and energy goes on on the way you now realize you need a new bottle. Okay? For instance, not necessarily in Coke bottles, but maybe something that is related more to places where you need the bottles to work, or it's a drug that you need to consume, and you need to take it on time.
But potentially we can have leaner supply chains if we can, more efficient supply chains if we're ordering just in time.
Exactly.
and it's kind of taking the Amazon model of getting the right product to the right place at the right time, but instrumenting it so that consumer packaged goods companies can kind of take control of that, and retailers can take control of that as well. Do you have a demo to show us? I know you guys were working on something. If the demo gods come together.
So yeah, here's a demo of a sensor that is monitoring pressure changes inside a pipeline. A very simple concept. If you want to monitor if there is a pressure increase for some reason, there's a blockage in the pipeline,
right.
Or if there's a leakage, you would have a drop in the pressure. So this monitors the pressure inside a tube non-intrusively, from just figuring out how the tube deforms, expands or shrinks. So, and this is of course hooked up to a wireless module, in this case BLE, low energy.
Okay, well, let's have a look.
We see demonstration of a self-aware pipe that is aware of pressure changes within the pipe. I increase the pressure with this piston, and after 5 seconds there is a blockage alert that alerts of this abnormal increase in the pressure. And then when I release the piston and the pressure drops, then eventually there will be an alert of a leakage indicating that the pressure has gone down. So the way that this works is simply Bluetooth sending out, transmitting the information from the sensors, the self-aware pipe, to the smartphone as a gateway and upload it to a cloud. And here we see the dashboard showing these pressure changes within the pipe. So yeah, neat self-aware pipe.
And so how accurate, you said it's accurate, but how accurate, what kind of sensitivity is there in terms of pressure or weight? Can you quantify it?
Okay, so basically it can sense down to milligrams. It has a milligram resolution in terms of the weight. So
what does that relate to?
That's related to even drugs.
Like pills.
Pills. And of course, feeling the weight of a small pill bottle
or perfume bottle.
Perfume bottle, yeah. So yeah, that's as sensitive as that.
Mind-blowing. How did you guys, so who are you guys? Where did you come from? How did you figure this stuff out?
It's the laboratory of Professor Hussam Haik. He's a staff member in the chemical engineering department in the Technion, Israel Institute of Technology.
Which is just this legendary academic research organization.
Yes, well, it's Israel's, I guess, most famous or most, I guess, first technological institute. And there's a lot of research going on there, and it's has a lot of orientation towards technology and implementing technology, applied technology. And specifically in the laboratory of the professor, me and my partner, Dr. Metal Segev-Bar, we did our master's degree and PhDs in nanotechnology. I finalized about 2.5 years ago, and our research was around flexible sensors based on nanomaterials. And we Metal and me, we met over when we were working in Tower Semiconductor. It's an Israeli fabrication line, a company that manufactures CMOS-based chips. And so we kind of already knew each other, so when we were in the academic studies, we started working together and found out there's a lot of neat stuff to develop based on these nanomaterials, and this was our main research, was developing these flexible sensors, which are good for what I just described, sensing deformation and very
What stage have you got to in the development of the product?
So we, right now, we are already engaged in development of products together with a leading equipment manufacturer of industrial components. And we're working on smartifying already existing products, well, the next generation of their products, and to enable the new feature of predictive maintenance for these products. And we're already past POC stage. We're now under the development process together with this OEM. And we are looking for additional strategic partners to develop additional products that would be for best aim for us is large scale with large volumes, meaning like you described, perfume bottles, pill bottles, and so on.
Amazing. Well, this is fascinating. Thanks so much for coming to Wiliot headquarters here in Israel and telling us about what you're doing at FeelIt. I think this is going to be everywhere.
Yeah, it's really fascinating, and I really feel it's something that's there's this trend. And it's going to really change a lot of the way things are being, controlled and monitored, and supply chains. It's really fascinating.
Very disruptive. If people want to find out more, where do they go?
To our websites, FeelIt, www.feelit.tech.
Okay.
And and this podcast, all the
Absolutely.
information that we just talked about.
Yeah, another Mr. Beacon milestone. Thanks so much.
Thank you.
So did you have a chance to think about the songs that you would take to Mars?
Yes.
And what are they?
So the first song, it's "We Are the World."
All right.
Kind of thought about it that if I go to Mars, I'd like some song to to be related to my maybe childhood, something that can give me a link to
Yeah.
So I used to live in the U.S. when I was a child, and there was this program of USA for Africa, and they did this song. And
Yes.
it's a class. I was in a public school, I think with second grade, third grade. So we made these microphones, and they took like a video of each of the students in the classroom singing a phrase like one of the.
Yeah.
One of the singers.
Band-Aid. It was. I watched the same thing. Only there was a British version at Wembley, and they had like Freddie Mercury's maybe his best performance ever. It was unforgettable. The
Yeah,
whole
it's
nation.
really. I really, as a child, it was like, wow, all these singers coming together and for a good cause. So it really left a good impression on me.
What a wonderful choice.
Yeah.
So that's number one.
So that's number one. And the second one is "Wish You Were Here," Pink Floyd. It's like I would say if I'm on Mars, I would have like the wish for a little bit something I don't have right now is back home maybe. So wish you, a little bit mellow song.
Yeah.
Which
Is that off Dark Side of the Moon? That's actually the album.
Wish You Were Here.
It's the actual
and there's a
album.
song
Okay.
Wish You Were Here. So like it's
All
like
right.
also really a very familiar song for me, and I really related to it. And the third one, it's like a more happy and more this last years. It's Mekaba of Jane. It's like a pop song, really cool, talking about also the world, how people connect, and it's like you can dance to it. So it's like a cool song.
Good to have something to dance to.
Yeah.
Very
Something,
good.
cheerful. Yeah.
Excellent choice. Thank you very much.